Have you ever wondered what light truly is and why it behaves the way it does? Let's start a journey to explore the mystery of light. Picture this. Light is a form of energy that our eyes can detect. It's like an invisible courier, delivering packets of energy from the source to our eyes. This energy, known as light, is famously swift, racing through the universe at an astonishing speed of about 186,000 miles per second. Yes, you heard that right. Light is the fastest thing in the universe, so fast that it can travel around the Earth 7.5 times in just 1 second. From the moment we wake up till we fall asleep, light is an integral part of our lives. It's not just about seeing, it's about experiencing the world around us. Light, in essence, illuminates our world and allows us to perceive it. But what makes light so unique and essential? Well, let's dive into the intriguing properties of light. Light, an energy that helps us see the world around us, has a dual nature. It behaves both as a particle and a wave, a phenomenon we call wave-particle duality. This means that light can exhibit properties of both particles, like electrons and waves, like sound or water waves. Another fascinating feature of light is its speed. Light travels at an incredible speed of approximately 300,000 kilometers per second in a vacuum. This speed decreases when light passes through mediums like water or glass. Light also has the ability to be reflected and refracted. Reflection is when light bounces off a surface, and refraction is when it changes direction as it passes from one medium to another. These qualities of light are fundamental to many of our daily experiences, from seeing our reflection in the mirror to rainbows forming in the sky. These properties make light a fascinating subject of study. Sir Isaac Newton, a name synonymous with gravity, also had theories about light. What were they? Well, Newton proposed the corpuscular theory of light. This theory suggests that light is made up of tiny, discrete particles, which he called corpuscles. Newton believed these corpuscles were emitted in all directions from a light source, like a lamp or the sun, and traveled in a straight line until they hit an object. He explained that when these particles strike our eyes, that's when we see light. He also proposed that different colors of light are due to variations in the size of these particles. Red light, for instance, was thought to be due to larger particles, while violet light was due to smaller particles. However, this theory couldn't explain phenomena like interference and diffraction, which led to its eventual downfall. But don't dismiss it just yet. Though not entirely accurate, Newton's theory paved the way for future discoveries about light. So, how does light actually travel? It's a question that has intrigued scientists for centuries. You see, light doesn't just take one path, it has two different ways to travel, as a ray and as a wave. In simple terms, when we talk about light as a ray, we're referring to the straight line path that light follows. This is easy to visualize, right? Think about how a flashlight shines its light in a direct, straight beam. Now, let's consider light as a wave. This concept might be a bit trickier to grasp. Imagine the ripples created when you drop a pebble into a pond. Those ripples spread out in waves, don't they? Similarly, light can also spread out in waves. This dual nature of light, known as wave-particle duality, is a fundamental concept in quantum physics. It's like light has a split personality, sometimes behaving like particles, other times like waves. Understanding the nature of light is essential to understanding its behavior. When you look in a mirror, you see your reflection. But how does light make this possible? Let's delve into an exploration of reflection, the phenomenon that plays a crucial role in how we perceive the world around us. Reflection, in the context of light, is the process where light waves return back into the medium from which they originated. Simply put, when light hits a surface, it bounces back. This is why we can see ourselves in a mirror. The mirror reflects the light that falls onto it, and our eyes perceive this reflected light, forming an image of ourselves. Now, there are two types of reflection: regular and diffuse. Regular reflection, also known as specular reflection, is what you see in a mirror. The light rays hit a smooth surface and bounce back in a predictable, consistent manner. The result? A clear, sharp image. On the other hand, diffuse reflection happens when light rays hit an uneven or rough surface. The light rays scatter in various directions, and the image is not clear or sharp. This is why you can't see your reflection in a rough wall or a bumpy surface. Diving deeper into the science of light, there are two fundamental laws that govern reflection. The first law states that the incident ray, the reflected ray, and the normal to the surface of the mirror all lie in the same plane. The second law, known as the law of angles, establishes that the angle of incidence equals the angle of reflection. These angles are measured with respect to the normal, an imaginary line perpendicular to the mirror surface at the point where the incident ray strikes. These laws of reflection are universally applicable, whether it's the light from a flashlight bouncing off a mirror in a dark room or the sun's rays reflecting off a tranquil lake. Reflection is a fundamental behavior of light that enables us to see the world around us. So the next time you catch your reflection in a mirror, you'll know it's all thanks to the fascinating science behind light and reflection. Ever noticed how objects appear different in various mirrors? What's the science behind that? Let's dive into the fascinating world of images. Images, you see, are not just reflections or projections. They are the result of a complex interplay of light and surfaces. There are two types of images: real and virtual. Real images are produced when light rays meet after reflection or refraction. They are inverted and can be captured on a screen. Virtual images, on the other hand, are formed when light rays appear to meet at a point behind the mirror or lens. They are upright and cannot be captured on a screen. Mirrors and lenses can alter the appearance of images. Concave mirrors and lenses, for instance, can magnify images, while convex mirrors and lenses can diminish them. These alterations are the result of the way these surfaces bend light rays. Images, whether real or virtual, are shaped by the behavior of light. Light, as we've seen, is much more than what meets the eye. It's an energy form, a force that shapes our world and our perception of it. From the moment the sun rises, casting its warm golden rays across the earth, to the artificial lights that illuminate our homes and cities after dark, light is everywhere. It's an integral part of our everyday lives. Let's briefly recap the fascinating journey we've embarked on. We've learned that light possesses a dual nature. It behaves both as particles, as Newton proposed, and as waves, a phenomenon perfectly exemplified by the mesmerizing patterns created when light passes through a prism. We've also touched upon the concepts of reflection and refraction. Reflection, as you'll recall, is the process by which light bounces back after striking a surface. This is the principle that allows us to see our reflections in a mirror. Refraction, on the other hand, is the bending of light as it passes from one medium to another, giving rise to some of nature's most beautiful phenomena, like rainbows. Our discussion on images, both virtual and real, further emphasize the role of light in our perception of reality. The images we see are nothing but light bouncing off objects and reaching our eyes, creating a visual representation of the world around us. But light isn't just about science. It's about the magic it brings into our lives. It's about how it makes us feel, how it influences our mood and emotions. It's about the warm glow of a sunset, the twinkle of stars in the night sky, the rainbow after a rain shower. Light is the magic that paints our world with colors and brings it to life. So, the next time you switch on a light or look in a mirror, remember the incredible science behind these everyday phenomena. Until next time, stay curious and keep exploring.